Hello. Hi guys, good morning. Welcome back to the new video. Firstly, before starting this video, if you have just read the problem itself and still you have not got the idea of what gonna be applied, I'm not saying that you will be able to solve it or you should solve it, but the idea of what should be applied in this problem should be very clear by just reading the problem itself. If not, then please read the problem again and find that one line or 2-3 words which can actually, because we say those words for those problems every day. We do that. So better you should find those 3-4 words or a line which actually make you think, okay, the algorithm which can be applied in this problem is this one. So yeah, without further ado, let's start the problem itself. It's pretty easy problem, pretty standard, pretty basic. You are having a zero index integer 2D array called as questions. Okay, 2D array, no worries. Where the question of I, where one question represent points and a brain power. Although in the next line it is explained a few things about that, but I'll just explain in a brief. What it means is points you will get if you just solve this question, and if you just solve this ith question, you have to skip next brain power of I questions. You have to skip and you have to move on to the I plus brain power of I plus 1th problem. Cool. Let's see. The array describes the question of an exam where you have to process the questions in order from 0, 1, 2 like this, starting from the question 0, and make a decision whether to solve or skip. See, it is marked in bold also. Whether to solve or skip. It is those 3 words I was saying, solve or skip. You have, for a question, you have 2 options, solve or skip. For sure, you should have thought of DP should be applied here. Although, if you are solving it for the first time, maybe you have not solved many of the DP problems yet, maybe you have only solved 2 or 3 problems, then I can consider, okay, you can watch this problem entirely and we will actually show you, okay, how the DP is actually working. But for the folks who have solved, let's say, more than 40-50 questions of DP and still by reading this line they can't figure out, then just make sure, like, mark in your notes whether you have 2 options. There's a high chance DP can be applied there. Cool. Solve or skip each question. Solving question I will earn you points, I points. Cool. Okay, if I solve the question, I will earn these points, I number of points. But we will be unable to solve each of the next brain power of I questions, which means I have to skip the next of the brain power of I questions. Now, if you skip the question I, then you can easily go and solve the IE plus 1 question, which means the next question. Cool. For example, it is given that, okay, if I just solve this question, then I will get the points as 3, but I will have to skip the next 2 numbers. I will reach on to the 3rd problem. But if I opt to skip this problem entirely, then I can just move on to the next problem itself, which is this problem. And you can see easily I can perform the same stuff here. Opt to solve it or just skip it. Cool. We have to ultimately find out the maximum points you can earn for the exam. Maximum points to be earned. Operations, 2 operations, solve it or skip it. Standard DP thinking should be there. Basically, by the question itself, we know that, okay, the DP is being applied, but still for the folks who cannot figure out that why the DP is being applied, let's look at, okay, how the recursion is working, why we have the repeating sub problem, and why we will apply DP. As standard, firstly, let's look at the example itself. As you see the first problem, I have just marked the questions like this. These are the 4 questions. I have just shown you like this, points and the brain power of I. So to actually make you visualize better. So I will just grab this first one. Then I'll just get the points as 3. Plus, I have to skip the next 2. I will skip the next 2. Then I will just move on to this. Then I will get the points as 2. Now my points are 5. I have not gone on to every point as such, which means, okay, it will just try for every possibility to find the maximum number of points. But yeah, maximum will be by this way. For the next example, maximum will be by, if we just grab the 2nd point, which means he skips the 1st point, it move on to the next point. If we just grab the 2nd point, he will just grab the point as 2. question when I say he will grab the point as 2, then he have to skip the next 2 points. If we go on to the next question where the points are 5, number of points are 7, maximum number of points he can grab for this exam. Cool. Now for sure, let's handle thinking if we are standing at 0, because we are said that we have to go from 0 to n, right? We are standing at 0. Here we have two options: solve it, which means take it, or leave it, which means skip it. Cool. If I just solve it, then what will happen is I will just get the points of this, which is 3. I'll get the points, but the next thing which I can solve now will be nothing but skipping 2 next of this, which means it was at I equal to 0. I skipped the next 2. I skipped this one. It will reach at 2, 3, which means at I equal to 0, I skipped 2 and reached what? This 3. 0 plus 2 plus 1. 1 plus is to actually show you, okay, I'm actually, because see, if I just do only plus 2, then I will reach on to the second element, but I have to reach to the third element, which means after the second element. Thus I just did a plus 1. So you will see it is nothing but 0 plus 2 plus 1, where 0 is nothing but the current index, ith index, plus 2 is the brain power of that ith index, and plus 1 to actually move on to the next element. Cool. So I just get this 3, and plus I will just call the function, okay, just give me the answer for the remaining part, but remaining was starting from here itself. Cool. Then again at this point of time where my I has landed here, I again have two options: take it, which means solve it; leave it, which means skip it. Skip this question. If I solve this question, I will get the points as 2. My earlier points were 3. Because of this, one option was to add the points as 2. Now the points are 5. Here with this, if I just leave it, so I will just leave it, which means I will just go next. When I leave it, I just go on to the next question. Next is nothing but empty, so nothing will be there. So basically we'll say, okay, if I just take it or leave it, whatever maximum will come, I'll just grab it. So maximum came 2, so I'll just grab 2, and I just, okay, added this 2 with this 3. So basically I'm just thinking, okay, what would be the maximum score I can get by taking it or by leaving it? As simple as that. So I just have one option, take it, one option, leave it, and whatsoever gives me the points, I'll just take the maximum out of both of this. Cool. As you're standing on the ith number, which means the 0th number, first option was, as I showed you, that for sure I can just take it. So I just grabbed this number and I just moved on to the I equal to 3 number. But what option was, maybe I should have leaved it. Then if I just leave it, then I just move on simply to the next number, which means I equal to 1. Now here also again I have two options: either I will just take it or leave it. If I just take it, then I will just get the points as 4, because ultimately here was points as 0 so far. So points will be in total will be 4 plus nothing but it will just call for the next. Next was, it is standing at 1. It has to skip the next 3 numbers and it will reach, okay, the next number after that 3 numbers. It has to reach the index 5. And as we know that, okay, we only have up to index 3. So for sure it will return a 0. As simple as that. And what if I skip this particular one also, which means the first question also, ith question, then I will reach on to I plus 1, which is the next question, and I again have to call the same function, which is f2, and from here. As simple as that. Now you will say, okay, Aryan, we saw this above thing, and although the problems was repeating, but I'll still show you that how the problems were repeating. So basically, recursion we saw, but also there are many repeating sub problems. Basically, if we just see the recursion again, what's happening is I am just standing here. Cool. I'll just skip it or opt it. If I just skipped it, then I'll just move on to the next number. If I just opt it, then I will get this point, and then I will have to call for the next number, which is this number. Cool. From I equal to 2, I have to call. From here I have to call, right? F2 I have to call. And same again, grab it or leave it, as simple as that. Here also, if I'm just standing here as this, then I have not grabbed any point. I just moved on to the next number, which is f of 1. I'm just saying, okay, indexing based, because you see f of 1. Then here again I have two options: leave it or take it. Cool. If I just take it, then I will just grab this number, the points are increased by b, and then it will just go on to d. Cool. If I just leave it again, then I am just again reached to c. So it is nothing but f of 2 again. You see it easily. You are computing the same stuff again and again. F of 2 was here also, f of 2 was here also. So you are repeating the sub problem again and again. That's the reason in a recursion you have to apply the DP so that you can actually store that. Okay, for this f of 2, my answer is this. So don't compute that part again and again. That's a standard DP technique. That's the reason I said if you have just seen firstly, you should have made sure that when you saw that word, solve it or skip it. The first thing, I'm not saying it should always work, but the first thing which should come in your mind is a DP. And as for sure, we just try to make the tree out of it, or maybe if you are just good at it, so you can also go via the bottom up approach, which is actually the easiest to think when you are much more familiar with DP. But if not, then it is always a point that okay, start with the recursion, do a memoization, and then maybe you can just do a bottom up if you think okay, optimization may be possible or not. Cool. Okay, now we know that okay, DP can be applied as simple as that. Firstly, for recursion, we will do the exact same stuff as we saw above. That okay, just for a question, we can take it, so the points will be added. Next, I can move on to is I plus power, the brain power of I plus 1th question, or if I just leave it, then I can just move on to I plus 1th question, which means firstly I will just call this recursive function from my main function. Then it is a main crux of this whole function, which is a recursive function. As for sure, recursive condition has 3 things: base condition, main condition, and then a return. Base condition is nothing but what if your index, which is idx, if it reaches end, or maybe after end, beyond end, for sure, right? It can reach beyond end, as you saw above also. Yeah, as you were doing here, then as you landed here, then after it will go somewhere else. If you just land here, it will go somewhere else outwards. So still I have to return a simple 0 because no points will be added if it just goes outwards. So if index is more than equal to my questions of size, then I can just return a 0. As simple as that. Now I have 2 options: to grab it or to leave it. Take it or leave it. If I just take it, then what will be the points I will have? I will have the questions of index of 0 point. I am starting at the index idx, and the points are represented by the zeroth index of that idx, because it's a 2D array. So the points I will grab by standing at the ith idx index is the question of idx 0. But now the next question I have to move on is nothing but idx. Like right now I'm standing the brain power of that idx plus 1, as I showed you, and like other part is nothing but simple, the same thing which is being called questions, just passing the array. Other part was leave it. If I just leave it, then I was standing at idx, right? I will just move on to idx plus 1. Cool, moving on to idx, which means I am just skipped idx, so no points of idx was being counted. Cool. Take it or leave it, just grab maximum out of it. I just grabbed it, I just return it. But as we saw that it has repeating sub problem, so just do a simple 3-step memoization. I will just use a DP array to memoize, nothing but very easy. Just make a DP array to actually memoize a solution. Initialize with -1. Cool. As we go on to a number and see if the DP of that idx is not -1, which means I have found a value for that idx. If yes, then I will just return the DP of idx. But if it is not, then it will just go on inside, and while returning back, it will just update that value to the idx, which means DP of idx, so that next time the same idx would come in, then it will just be it won't be having the values -1, and I will just say okay, for sure you can just return the DP of idx value. It was the simple memoization. Time is nothing but O of n. Why? Because of this DP array, you are going on to every state, which means I state, because it was a linear array, you are going on to every state exactly once. And for sure, the space is also O of n, because you are actually using a DP array for storing your numbers. Now, although you are done with the questions, you can't just improve anything, but for the folks who are actually been doing DP for a few time, it's actually, see, whenever it's a linear DP, it's very easy to think of the bottom up approach, because linearly our minds can think very easily for the like normal human brains. While for if you just go on and see, so it is just better to actually see on the bottom approach as well. I'm not saying okay, like you can just leave the video, but it is good to actually understand this bottom approach, because it's very rarely asked in the online assessments and interviews, like especially online assessment, because the problem A or problem B, because in online assessment you have problems which are 3 mostly. For the problem A or B, it can be a linear DP. There's a high chance. Cool. So basically, as for recursion, we saw that we started from the left, index 0, and then ultimately recursion, what it does is internally, you start from 0, then it will just go on deep, and while returning back, it is computing the answer. So from left, you go on, the recursion will go on to right, and while returning back, you saw now, while returning back, it is computing the answer. It is a recursion. While and whatsoever is in the bottom is okay, the operation it does while returning back. So while returning back, it is computing the maximum. Cool. So basically from left, I am going to right, and from right, when it is coming back, it is computing the answer. I can just repeat the same stuff. While coming back from right, which means I'll come from right to left, and I'll just keep on computing the answer by taking the maximum out of both the results, which means, you know, take it or leave it. Cool. I'll just do the same stuff, which means how we assume it to be that, okay, if I'm standing at the ith index, I just assume that I know one thing in mind. I have computed my result from right to left, which means this whole part is computed for me, and I'm computing the result from right to left. So if I'm standing at I, it is how you will think in actual problems itself. If you have to do a bottom approach for a problem, then you will just assume that, okay, you are standing at this index, you have the result, whatsoever you want, you have the result from the back, and just start to find the condition for this ith value. Then you can maybe, like very later, when you have found the condition itself, then you can maybe move on to the base condition of these stuff. But how you think of is, okay, you just stand on the mid and assume that you have the values whatsoever you want. I'm not sure what values I want, but whatsoever I want, I have from back. Cool. Then I have two options: to take it or to leave it, skip it. If I just take the ith number, which means the questions of I of 0, which means the points of question of that question will be added, and the next thing which I have to go on is nothing but which means I just skip, because if I'm standing here and I just say, okay, the brain power is 1, so I have to skip one question, right? So I also need to make sure, okay, whatsoever maximum has been there from that part, I have to grab that, and that will be stored in my DP itself. So I'll just grab the DP of I means, as I showed you, I plus brain power of I plus 1, to actually say, okay, I'll just skip these brain power of I numbers, and I will reach on to the new index, and it will have, okay, whatsoever answer is there. And answer is nothing but, for sure, what's the answer? Answer is nothing but your maximum points you can earn. So basically it will be nothing but the maximum points you can earn from up till here. So basically you will have, okay, maximum points you can earn up till here, and you will just grab this answer. Another option for sure we had was, okay, just skip it, which means I'll just leave it. If I just leave it, okay, what option I had? Just move on to the next one, which means I will just grab, okay, whatsoever answer I had up till maximum up till this location, which means I plus 1 location, which is DP of I plus 1. And that is these two condition. And ultimately what I want is, take it or leave it, have the maximum. So I will just take the maximum out of these two. As simple as that. Code is pretty simple. Firstly, for sure, I will have my DP array initialized with 0, because I have to take the maximum. All right. Cool. Then I will just go on from the end to the start, as we saw. Okay, that we just thought of, okay, from end to start it is being computed, being added. Now to make the life easier, that, okay, it should not cluttered, I have just marked points and jumps. Basically points is, if you just grab that ith question, then you will just get this point, and if you just grab it, then you have to jump the next these jump questions. Now if you just have to jump, then the next question you will land at would be nothing but I plus jump plus 1, as I showed you above. Also it is nothing but I plus jump plus 1. Cool. But as we saw that, okay, we have a bound of n, because we can't take our array entirely it is the bound up till n only. I can't take the array entirely, so I have to just park the condition. Okay, it can go because I plus jump can be anything very big, so I can go way beyond n also. So I have to put, okay, the limit up till n only, because thama up till n only, go. And then I will just, okay, my next question will be at max up till n, and for sure at n I have stored a value as 0. So even if it reaches beyond my n minus 1th range, because up till n minus 1 only I have elements, right? If it even reaches beyond n minus 1, which means if it even reaches n, then also I will return a 0, because no points will be given from that point. Cool. Then I will have a dp of I, which will take the maximum of what? If I don't grab it, which means I skip the ith number, or if I just grab it, then I will just get this point, and I know that I have to get the dp of this next question, and next question we already saw above. And that is all. Ultimately, as we are moving from right to left, so ultimately our answer will be stored at dp of 0. That does, I will just have return dp of 0. Time complexity is same as O of n, because we are just moving on the array linearly from right to left. It is just one iteration. Space also often, because we are using a dp array to actually store our end results. The code for C++, Java and Python is down below. It's all the very easy. You should actually implement by yourself. That's all. I hope that you guys liked it. See you in the next one. Bye. Take care. Sorry. How was this? Smoking kills. Don't smoke. Do vape instead.